Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to continue solving June 2024 questions from paper 2 pure mathematics with mechanics / statistics. So we are going to be tackling question number 4 in this video. Now if you have not watched the solution to question number 1, question number 2 and question number 3, endeavor to check the playlist of this channel so that you can easily access those videos. Alternatively, you can still check the comment section of this particular video you're watching now. I am going to indicate the links to those other videos so you can easily access the videos. If you're just joining us for your first time, make sure you like, share and subscribe to our YouTube channel. Do well to comment about the video in the comment section. So let's get started with what we have for you today. Alright, so question 4 had two parts. One part was 3 marks, the other part was 7 marks. The first part was from sequences and series, and the second part was from binomial expansion. So the first part reads, the first term and the last term of an arithmetic progression are 7 and 43 respectively. The sum of the terms of the progression is 250. Find the number of terms and the common difference of the progression. 3 marks. Second part, obtain the first 4 terms of the binomial expansion of 1 minus 3x on 2 all raised to the negative 2 and find the set of values of x for which the expansion is valid. Hence, state the first 4 terms of the binomial expansion of 2 minus 3x all raised to the power negative 2, 7 marks. Alright, so as a normal routine, what you do is that you pause the video, you solve the equation by yourself, you play the video and you follow the method to see if your own method and your solution are correct. So let's get started. Alright, so we are going to begin with the first part of the question. The first term and the last term of an arithmetic progression are 7 and 43 respectively, which means that the first term is 7 and the last term is 43. The sum of the terms is 250. So let's collect the data. A is the first term, L is the last term, and S of n is the sum of all the terms. We just say the sum of the first n terms, assuming that there are n terms. So A is 7, L is 43, and S of n is equal to 250. We are now going to find the number of terms, having in mind that our number of terms is n. Alright, so we are going to use the formula that says that the sum of the first n terms of an AP is n over 2 into A plus L. Actually, there are two different formulae. The first one is S of n, the one that we actually usually use more oftenly, is n over 2, where n is the number of terms, into 2A, where A is the first term, plus n minus 1, n is the number of terms, so n minus 1 is the number of terms minus 1 times z, and z is the common difference. Alright, but actually the last term of a progression is always its n term. Alright, so the last term is always the n term, and we know that if you are an AP, your n term is given by A plus n minus 1 times d. So your n term is A plus n minus 1 times d. So you realize that this 2A, we can to get back what is up here, we just need to add A to the n term. You see, so you see this portion is actually the n term of the progression, and the n term of the progression is always the last term in the series when we are summing, because we are going to sum from the first term to the n term. So the n term is the last term. That is why we now have the formula S of n is equal to n over 2, okay, into A plus L. Alright, because L is the last term and A plus n minus 1 times d is that last term. So this is a second formula we can use, because in the equation we don't have the common difference. We need to find a common difference, so we cannot use this first formula. We are going to use the second one that has the first term and the last term. So that was just a recap of a little concept in sequences and series. Alright, so having in mind that the sum of the first n terms is n over 2 into a plus l, where n is the number of terms, a is the first term and l is the last term, we just have that 250 is equal to n over 2 into 7 plus 43. Now 7 plus 43 is equal to 50. If we multiply both sides by 2, we get 500 equal to n times 50. Divide both sides by 50 and n gives us 10. So we actually have 10 terms in this arithmetic progression. How then do we find the common difference? We are going to use the knowledge that the last term is actually the n term, and since n is equal to 10, it means that the last term is the 10th term. So we know that the n term is actually a plus n minus 1 times d. It is actually 43, but for it to be 43, our n must be 10 because the 10th term is the last term, since there are 10 terms in the arithmetic progression. So we are going to have 7, which is the first term, plus 10 minus 1 times d equal to 43. D is a common difference. So we are going to have 7 plus 9d equal to 43. Subtract 7 on both sides, we have 9d equal to 43 minus 7, which is 36. Divide both sides by 9 and d is going to give us 4. So we are done with the first part of the equation. Number of terms is 10, common difference is 4. Alright, we are moving on to the second part of the equation 4. It reads, obtain the first 4 terms of the binomial expansion of 1 minus 3x to the power negative 2 and find the set of values of x for which the expansion is valid. Hence, state the first 4 terms of the binomial expansion of 2 minus 3x, all that raised to the power negative 2. Okay, so we are going to begin with the first part, which is x, which is obtaining the first 4 terms of the binomial expansion of 1 minus 3x on 2 raised to the power negative 2x. So we have a general formula which is actually in your formula booklet. So if I want to expand 1 plus x, all that raised to the power n, I'm using capital X, alright, not small x, because I want to show you guys something later. So 1 plus x to the power n binomial expansion is equal to 1 plus nx on 1 factorial plus n into n minus 1 times x squared on 2 factorial plus n into n minus 1 into n minus 2 x cubed on 3 factorial, and so on and so forth. Since I need the first 4 terms, I have the first term, the second term, the third term, and the fourth term. I'm not going to go to x to the power 4 and all the rest. I'm just going to end here. Okay, so in this case, you realize that this 1 minus 3x on 2 raised to the power negative 2n, if we compare this guy here with 1 plus capital X to the n, what do we realize? We realize that 1 and 1 are already equal. Your capital X then becomes negative 3x on 2, and then your n becomes negative 2. So all we have to do is substitution. We just replace n with negative 2 whenever we see n, and we replace capital X with negative 3x on 2 whenever we see capital X. So let's go. The first term stays as 1. The next term, our n is negative 2. So here's the negative sign attached to the 2. And your capital X is negative 3x divided by 2. Let's go to the third term. Your n is negative 2. So n into n minus 1 becomes negative 2 into negative 2 minus 1. Then your capital X is minus 3x on 2. We need to square, then divide by 2 factorial. And the fourth term, we have n into n minus 1 into n minus 2 first. So we have negative 2 into negative 2 minus 1 into negative 2 minus 2. We now multiply with x cubed, which is negative 3x on 2 all cubed. Then we divide by 3 factorial. So all we have to do now is simplification. Alright, so we are going to simplify term by term. So I've simplified already, so I'm just going to be explaining how I simplify. Alright, so the first term is 1, it remains 1. The next term, you see, the negative sign here with the negative sign here gives us the positive sign. 1 factorial is 1. 2 divides with 2 and we are left with 3x because the negatives have already multiplied to give us positive. So the second term is 3x. Let us go to the third term. Now in the third term, we have a negative sign here, we have another negative sign here. When we square negative, we are going to have a positive sign. So we are going to have here negative times negative is positive. Okay, so the resulting sign is positive. I'm dealing first with the signs before the numbers, so the resulting sign is positive. Now let us go to the numbers. When I square 3x, I'm going to have 9x squared. Yes, 9x squared. When I square 2, I get 4, but since it's in the denominator, it can move down to meet 2 factorial. That's why you see me writing 4 times 2 factorial. Now I have 2 times negative 2 times negative 3, because negative 2 minus 1 is negative 3. Negative 2 times negative 3 is positive 6. Alright, now let's go to the last guy here. Let's begin with the signs. In fact, this man is negative 2. Okay, this man is negative 3. Alright, and this man is negative 4. Negative 4. Alright, so let's multiply the signs first to get the resulting sign. Now there is a negative sign that will be here because when we cube negative, we have negative. Alright, so we are going to have negative, 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 negative. We have 4 negatives. That's taking negative to an even number. So the resulting sign is going to be positive. Now 2 times 3 times 4 is 24. 3x cubed is 27x cubed. Alright, 3x all cubed is 27x cubed. 2 cubed is 8. It goes to the denominator to meet with 3 factorial. That is why you see me writing 8 times 3 factorial. Now simplification, finally, we are going to have here 2 factorial is 2 times 4 is 8. 6 over 8 then times 9 will give you 27 on 4. Alright, now this last term here, 3 factorial is 6 times 8 is 48. 24 on 48 is half. Then we are left with 27 in the numerator, 27x cubed. So this is a binomial expansion. These are the first 4 terms of the binomial expansion of 1 minus 3x on 2 raised to the power negative 2. Next question, we need to find a set of values of x for which this expansion is valid. So generally, a plus bx to the power n is valid if and only if the absolute value of bx is less than the absolute value of a. That is the general principle. So in this case, we realize that our a is 1 and our b is negative 3x on 2. So for our expansion to be valid, we need that the absolute value of negative 3x on 2 is less than the absolute value of 1, which is just 1 because your a is 1. Alright, so you realize that if you just multiply both sides of this inequality by the absolute value of 2, because remember that the absolute value of negative 3x on 2 is the same as the absolute value of negative 3x divided by the absolute value of 2. Alright, so if you multiply both sides by the absolute value of 2, we are going to have the absolute value of negative 3x is less than 2 because the absolute value of 2 is 2. The inequality sign remains less than because that absolute value is positive. From here, the absolute value of negative 3x is the same as the absolute value of negative 3 times the absolute value of x. But the absolute value of negative 3 is 3, so we just divide both sides by the 3. We are going to have the absolute value of x less than 2/3. And by definition, if the absolute value of a function is less than another function, it means this function that is inside the absolute value is between the negative and the positive of the function on the right hand side. What I'm saying is that your x, which is inside the absolute value, is between negative 2/3 and positive 2/3. That is a definition. Alright, so these are the set of values of x for which the binomial expansion of this quantity is always valid. Alright, now we need to get the first 4 terms of the binomial expansion of 2 minus 3x to the power negative 2. Now we are going to keep this result. Alright, now this, you realize that this 1 minus 3x on 2 to the negative 2 is equal to the LCM is 2, alright? So you are just going to have 2 minus 3x all divided by 2, then raised to the power negative 2. From the law of indices, we can separate the numerator and the denominator and attribute the powers to both of them. So you are going to have 2 minus 3x to the negative 2 divided by 2 to the negative 2. Now 2 to the negative 2 is just basically 4 to the negative 1, alright? In fact, 1 over 2 to the negative 2 is equal to 4. It's just 2 to the power. When we send it to the numerator, we have 2 to the power 2, which is 4. Okay, so from here we realize that this guy here is equal to 4 times this guy. So what is this guy? We divide both sides by 4, and we have that this guy is equal to this guy divided by 4, or 1/4 times this man. But we already have the first 4 terms of the binomial expansion of this quantity. We had it already, alright? So it means that the first 4 terms of the binomial expansion of this new quantity is 1/4 times the first 4 terms of the binomial expansion of the previous quantity we already had. Multiplying all through by 1 and 4, we are going to have the first 4 terms of the binomial expansion of 2 minus 3x to the minus 2 to be 1/4 plus 3/4 x plus 27 on 16 x squared plus 27 on 8 x cubed. So those are the first 4 terms of the binomial expansion of the new quantity. So I think with this we have come to the end of the video. Thank you guys for staying till the end. If you love the video, like, share and subscribe to the channel. See you guys in the next video where we are going to be tackling question number 5. Until then, stay blessed.